So as you can see here, the user has this guided workflow, this user interface here. We have been trying to keep this quite simple and straightforward to use. The first task to go through is, of course, getting your data into the oil palm application. Here, the import data action. The user can come down and select the data layer that they would like to add. In this case, I have some data available. I'm going to simply select the orthophoto RGB. So this is with red, green, blue bands. I'll open this. If your data has different combinations of bands, you can then come into the display settings and define whether your red, green, or blue is as 1, 2, or 3 here. This is a layer stack, so I can select which corresponds to the red, green, or blue in this portion. In addition, I can select what general settings I would like to use in terms of the area. So we can use acres, square kilometers, hectares, square meters. I'll just take square kilometers for this demonstration. And then confirm. Once you see the check mark appear in your workflow above, that means you've fulfilled all the conditions of this action and can move on to the next step, which here is loading and defining blocks. Now the blocks are the polygons that make up the plantation boundaries. Those may be available to the analyst ahead of time in the form of a shapefile. If so, you can come into the settings and select import from shapefile. If they're not available, you can draw your own blocks through manual creation or simply use the whole scene for the analysis. So I have my blocks in a shapefile. I'll choose to import those. Simply then click on Browse, navigate to the SHP file, and click Open. See now the outlines of my plantation block here in yellow. I will save these settings, and again, once I see my check mark, I can move on in the analysis. The next block is whether I want to utilize elevation data for my analysis. Like I said, within version 9 or within version 1.2, you have the choice of using elevation data or not. And we're going to say continue without DSM or DTM data at this stage. I will click Save. Again, I can now move on. Come into the Detect and Analyze Palms phase here. And first of all, within the Detect based on orthophoto, here the user can select what band they would like to use to generate sort of the template matching phase of that's the technology behind this part of the project. And typically we always suggest to use the green band, so we just ask the user to select which band corresponds to their green band. In my case, it's number 2. You also have a sensitivity field here. The more we increase this slider, the more sensitive the detection will become, and the more palms will be detected. Our recommendation is what is here in the default is 0.7. So I will maintain that for this analysis. We then have the option whether we want to detect the so-called anomalies, so whether trees are healthy or not. For this, we typically use an NDVI threshold. As you know, NDVI is based off of the red and the near-infrared band. In this image, I don't have a near-infrared data, so I have 2 options. Either I can leave this blank, not detect anomalies, or we also provide you with the option of generating the green vegetation, the green-red vegetation index, that GRVI, that can all be used as an alternative. So that just means I have to substitute my green band here for the excuse me, green was my number 2 here for the NIR band. Once I have this set, again, I can also adjust my threshold in terms of what palms will be classified as anomalies or not. This, you can again use the slider to move up or down to make this more sensitive or not. When we are happy with the settings, we can then click on Detect Palms, and depending on the size of the imagery and the complexity, this could take a few moments to run, and we will see that when it is finished, not only will the individual palms be detected as a point, but also the different anomalies as well as the size of the palm. Just a reminder for anybody that came late, you can submit any questions via our chat capabilities, and we will have a Q&A after this demonstration. So here I now see some results. I'll zoom in here. Various zoom and display tools available. Pan around. In general, the detection looks rather well. We see some of the smaller palms here between the rows were not detected in this particular example, primarily due to the fact that this was based off of template matching and nothing to do with elevation data, since we had none. And next example, we'll see how elevation data can improve this type of analysis. If we're happy with these general settings that were used, we can then click Save and move on to the edit action, as it could be. As we can see here, some palms were missed, so we can come in and we provide very simple manual editing functionality here. We can add a palm. You can either choose the anomaly setting to add that, detect this automatically or not. We can also choose what type of crown size we want to add. So for example, I can select large. Now any palm that I click here will be added to the category large. In addition, you can do region-based editing, so we can select an entire block of trees. Do a brief example here. So here I see several trees that maybe they should all be categorized as anomalies, and I will come into this region. Once it is grayed in, it is active, and now I can say Edit Anomaly, and if I click this once, it'll add to one category, and now add it to a different category. So now these have all been categorized as anomalies here. And the same is true in terms of editing size or removing trees in bulk. Once we are happy with the edited phase here, zoom out to extent, we can save our results. This stage, they are saved just within our project here. And finally, we would like to export the results outside of the eCognition Oil Palm app. And here again, the users have a number of options. By default, you will see that the tree centers shapefile option is selected. This will export a shape file. Alternatively, you can look at tree crowns or the blocks, or select all three. This would then export 3 individual shapefiles, one representing the blocks that were selected or imported, the other the tree crowns with their associated attributes, as well as the tree centers. I mentioned earlier we would take a look at what these attributes look like. So you can, of course, turn on the Show Hide Attribute Table option here, and you see individual tree IDs, whether it was classified as an anomaly or not. By the way, when you click on a tree, the center of the zoom window will adjust to that tree. You also get information about the crown size. Here we didn't have any elevation data, so we don't have this information. You get information on density, the actual position of the tree. Again, here elevation and height information was not imported, so this is not available in this readout. And you also have information in the comment field on what approach was used to find this particular tree. So here we can select this, move this over a bit. We see that the template matching approach was used to detect this particular tree. If I scroll down to the bottom of this list, I see that I have manually added 3 trees here, so that information is also available to the user. Finally, we can also select to export the PDF report, which will give you various views as well as all the statistics that we see here. So this has walked you through how the oil palm application works with, I would say, standard RGB imagery coming from a UAV without the elevation data as input. Alternatively, we can use elevation data within the oil palm app. You can see here I have drawn a rough block manually and skipped ahead to the section where we select whether we want to utilize the elevation data or not. At this phase, I can come in and either use an existing DSM and DTM, or simply use a DSM from which I can derive my DTM in the oil palm application. So I'm going to import a digital surface model. I'd merely have to browse to that. Here I have my elevation DSM. Open this up, and I can now view my DSM here in the viewer. And from this DSM, I would like to estimate the digital terrain model. I have the option of defining whether the terrain is flat or has certain profile to it. Here, this is a flat terrain type. I will now select the Create DTM option. And again, it may take a few moments to run. Get the message that it is finished. Here is then the NDSM view. So once we have our DTM, we can generate an NDSM within the oil palm app that will be used in our analysis. We can also click to turn on our view ground option here. So we do an estimate of ground within this NDSM as well. If I'm happy with the results, again, I can select Save. This gets me back into the analysis as we have seen before. Come into my Detect and Analyze Palms section. Again, make sure that my green band is selected. Whatever sensitivity threshold that I would like to use is set. And now we have an additional sensitivity threshold here when we use elevation data. And this sensitivity is related to our elevation data set. And the higher we set our threshold, the more sensitive the analysis will be in terms of the elevation. So we will select a threshold here. You also see that we have additional settings here in terms of what is considered a small, medium, or large palm. The user can use the drop-down menus to select and define these. And then finally, again, the anomalies section. As before, I'm working with RGB data here. So my red was the band 3. Green, I'm going to, instead of creating an NDVI, I will create that the green-red vegetation index here. And now I will let my analysis run again. Note that the analysis only will occur within the block that is defined by the user. So depending how large an area that we are looking at, this will influence the processing time here. Now I can see that not only have I detected my larger palms, but you see now in between the rows that these smaller palms have also been detected. We also have a more representative crown estimate here, and the difference between the small, medium, and large, as was possible without the elevation data. Happy with these results, I will click Save, and then I have the option again of coming in and doing any type of editing. So again, may have to add trees if they were missed for whatever reason. These palms here were detected very well, but we notice there are limits, so that we have some very small palms off in this field here that weren't detected well. We also see a few errors. So here, and we can simply click on a palm if it's an error, and that will automatically be removed. And the user can come in and use the different views here. So we can switch to an NDSM view and see that there should be a palm here. Edit our size and make this a small palm to add or remove trees as needed based on different view settings. You can always toggle between view settings using the options here in the Analysis Builder toolbar. Go back to the red, green, blue setting here. And when you're happy with these results, always click Save, get the check mark. That means you can move on. If you need to go back, you can always click the Revert button and go back and continue editing the file. In addition to the elevation data sets for viewing, we can also view the density layer here, and this will give you this heat map on palm density within the plantation. It is also very useful information to have here. So, if there are any questions that have popped up throughout the presentation, please feel free to send these in. My colleague will forward me a few at the moment. So question one that I see, does eCognition offer the detection of other species like pines? That's an excellent question. The oil palm application, as the name implies, is designed specifically for the oil palm tree detection. But as some of you may know, we have other software packages available within the eCognition family, such as eCognition Suite, which includes eCognition Developer. The technology that is available within Developer was used to create the oil palm application. So you can make use of technology like template matching within eCognition Developer to use for, say, pine tree detection, but that would have to be done outside of the oil palm application. Again, this application is designed specifically for oil palm detection. Another question here. I've seen apps that can map the fields while the drone is in the air. So real-time live detection, this is not possible with the oil palm application as is. We are importing the data from a drive. This data has been orthorectified ahead of time. So if that type of analysis, that type of processing is required, there would obviously lead to certain lags within this. So depending on what type of, how data is saved and distributed, would obviously impact whether you can do live detection or not. Another question, what is an anomaly? Good question. This is a term that is used by the growers and plantation owners, and our software was developed in collaboration with some of these customers. Anomaly, by anomaly, we are referring to trees that are not as healthy as they could be, so sicker trees. Why that particular tree is not growing well is something that the field team will determine based on the information that we collect here.